was still trapped inside the sun. When we invented the wheel, it was bouncing. When we built Rome, it was bouncing. When we landed on the moon, it was still bouncing. It spent the entire history of human civilization just trying to cross a few 100,000 kilometers of solar plasma. This is where your intuition fails. We think of light as instant, but the universe is a slow, incredibly patient machine. The light warming your face is a literal relic from our deep prehistoric past. But wait, the long crawl is finally coming to an end. The photon has finally reached the outer edge of the radiative zone. And here, the rules of physics change completely. From a microscopic, agonizing crawl, the light is about to get caught in a colossal, boiling, cosmic conveyor belt. The journey is about to speed up in the most violent way possible. How does the sun suddenly throw this ancient light into overdrive? The answer lies in a boiling ocean of plasma. Look closely at what happens next. After tens of thousands of years of agonizingly slow, microscopic steps, the photon finally reaches a boundary. It crosses out of the crushing radiative zone and enters the convection zone. This is the outer shell of the sun, and here the physics shifts completely. The mechanism of moving energy changes from radiation to convection. What does that mean? Instead of photons slowly bouncing from electron to electron, the material itself begins to move. The sun starts to boil. Think of a giant pot of thick, bubbling soup on a hot stove. The hot soup at the bottom rises rapidly to the surface, cools down, and then sinks back down to get heated again. On the sun, this boiling pot is 200,000 kilometers deep, and the bubbles are the size of entire continents. Now watch what this implies. The photon gets swallowed by a massive column of rising hot plasma. Instead of crawling, it is now hitching a ride on a giant, superheated cosmic conveyor belt. It is being physically carried upward at speeds of hundreds of miles per hour. This is where your intuition fails. You might think this is a gentle, smooth ride to the top. Wrong. It is a chaotic, turbulent, screaming elevator ride. The plasma is churning, twisting, and snapping with intense magnetic fields. But for our ancient photon, this boiling chaos is a massive shortcut. A journey that would have taken another 10,000 years of random bouncing is suddenly fast-tracked. It covers the final 200,000 kilometers in just a few weeks. It is rushing toward the edge, cooling down even further as the pressure drops. The angry gamma ray is now gone. It has been stretched and softened into visible light, infrared and ultraviolet rays. It is finally ready for the outside world. But there is one final critical barrier to cross. The photon is still technically inside the plasma. It is still surrounded by matter that wants to trap it. How does it make that final leap from the boiling liquid surface into the empty, cold void of space? The answer lies in the ultimate boundary line. Let us look closely at the boundary where the light finally